My name is Scott Carlson. I'm with MTH Pumps. I've been here for over 20 years now. Um, yeah, I started out doing just graphics for the company, and my background before I got into doing graphics was doing computer-aided drafting and a little bit of engineering, um, as well as a lot of the artwork. So I got into the graphic arts, and Dave Germain, the founder of the company, hired me to do all the catalogs and brochures. And with my engineering background as well as all the graphics, I kind of naturally moved into the marketing realm of things, and it made it an easy progression. Um, I'll tell you a little bit about our company if you're not already familiar. We've been in operation since 1965. We're second generation owned. Dave Tremaine was our founder. His son Tim Tremaine is now the president of the company, and he does he has brought us into the turn of the century here with all our ISO compliances, and really grown the company quite a bit from where Dave started. We currently have 65 employees, and it says 65 on here, but I believe we've hired a few more people since then, so it is a little bit higher. All of our products are made in the U.S. Everything that ships out of our factory was made in our factory or locally sourced as much as possible. I believe there are one or two things that still come from overseas, but for the most part, everything is made here. We even own our own foundry next door to us, which pours brass, bronze, and aluminum, and has recently been outfitted to be able to handle small runs of investment cast stainless steel, which I'll get into in just a minute here. But like I said, we are ISO certified, and we have all the state-of-the-art machinery to be running machines 24/7. We are vertically integrated with our own foundry as well as our own pattern shop. And as the technology improves, the pattern shop is slowly being replaced with 3D printed machinery and robot controlled machinery as well. So we're just kind of moving with the times. A quick tour of our facility here. We just built a new sales office, which currently has about 6 salespeople available, including myself. We just hired a second application engineer, so we have 2 application engineers. If you have something that's a non-water application you need help with, they're very good. We do have a full R&D research area, including the ability to do full NPSH testing using water all the way up to above 212 degrees, which is kind of a rarity in the pumping world for being able to test with a full dynamometer. And like I said, we have a lot of state-of-the-art machinery, as you can see from our slideshow here, including our first robot arm, which we just had installed last year, which feeds our machine 24 hours a day, 7 days a week. So we are manufacturing enough parts to make sure that we can meet the supplies or the demands that we need in our factory. A few more pictures of our facility. We do have a full tool room available. We are also welding, robotic welding, CNC welding, some of our canned motor pumps now. We do have a full warehouse with millions of dollars of inventory to be able to provide you with great delivery times on a large percentage of our standard products. In fact, our normal lead time on a standard product is a 7 to 10 day lead time. However, we do have an expedite program that if you do need an emergency pump, we can usually get one out the door within 24 hours, sometimes quicker. Every single pump that we do ship out of our factory is 100% tested to its performance in our assembly and testing area. So every single pump that leaves our factory has been wetted, and we have a pretty advanced shipping capabilities. We can do multi-pack if you have any OEM demands that require less usage of packaging. We can always meet that with the multi-pack usage as well as the individual boxing. So whatever your demands may be, we can meet them.
Scott, if I may add something here just for a quick minute. This is Jim Shackman. Sorry to interrupt you, Scott.
Oh,
but on that Expedite program,
yes,
on our regenerative turbine pumps, if we receive an order, let's say of any given day by, Scott, I'm going to say it's 10 o'clock Central Time, which both of you are on, that if we have all the parts, we can ship them out the same day.
Correct. So yes, if we get an order by 10 o'clock in the morning under an expedite, we can have it out by about 3 o'clock in the afternoon, which is when the shipping picks up, usually for UPS or FedEx or whoever you set up with. We even have local customers or customers in Chicago who will send out pickup trucks to come get skids if they need to. We've had it happen before. So we're pretty flexible on the rush.
There is a slight fee for that, of course, on the expedite. But when a situation is with an end user needing a pump immediately because they're losing money because their system's down, they're willing to pay that.
Losing money, or if it's an emergency. For instance, when all this COVID started, the Army Corps of Engineers did have one of our distributors order several pumps when they outfitted one of the Chicagoland's closed down hospitals in order to be able to treat COVID patients. And we ended up 24-hour shipping several pumps out to them so that they, while they were rebuilding this hospital, to be operational within just a couple of days. So, kind of a unique situation that we were able to fulfill. So anyway, yeah, we're pretty flexible. Some of our associations and trade shows we participate in, if we ever get back to trade shows because of COVID. But the big one to note is that we are ISO certified, and later this year we are going to go from the ISO 9000 certification up to the ISO 14000, which incorporates all of the environmentally sustainable and environmentally conscious regulations possible in our current facility, as well as we are planning on being in a completely new building in the next 5 to 10 years because we have literally run out of room for any more machinery in our current facility. So that is coming down the road very quickly here. Moving along here, in-house capabilities. We do have a full engineering staff. They have their own building with their own R&D. So we can do a lot of rapid prototyping and a lot of testing. Like I had mentioned earlier, we have just outfitted our foundry, P&W foundry, to be able to do investment cast stainless steel on small runs, which means if there is a stainless steel part that needs a modification for a special job of something that we currently make, we can now do that in small runs of 1 to 2 pieces in an economical way, in a quick way. In fact, this small run foundry investment cast setup that we have has this quick dry system to it that I've been told only a handful of foundries in the country have right now, that can do the ceramic drying with the drying system in just a couple of hours. So when they do when they make the wax molds and they do the ceramic dip with the drying, the repeated dip and dry method, there's a special dryer that we have installed that will allow us to have that part ready to pour in a matter of hours instead of days. So that's something that we're pretty proud of right now. Moving along, a little bit about these characteristics of a regen turbine. The main characteristic of a regen turbine is that it is a high head with low to moderate flows, where you're probably used to a centrifugal pump, which is the most common pump in the world, where it's a higher flow with a lower head or pressure. And with a centrifugal pump, the higher the flow, the more horsepower that is needed. It's exactly the opposite with a regen turbine pump, where the higher the pressure, the higher the horsepower is needed. As you can see from the sample curves that I have on here, we have some of our C series, which are centrifugal pumps, where we can go out to 100 gallons a minute, but only hit about 60 feet ahead, where with our, and that's a 4-inch centrifugal, where with our 4-inch regen turbine, we're only doing maybe about 20 to 25 feet or 20 to 25 gallons per minute, but we're all the way up at 600 feet ahead. So the steep head capacity is the main characteristic of a regen turbine. To show you a curve up close, this is a 4-stage regen turbine curve. And as you add stages, it adds pressure similar to a regen turbine, but you can see it doesn't add any flow to it. So where you're only hitting 50 gallons a minute, we're hitting all the way past 1,600 feet ahead. So it's a very high pressure pump for moderately low flow.
Again, I mean, this is Jim again. If there's any questions from anyone at ePumps, please feel free to type it in as or ask it either way, as Scott said earlier.
Sure. And so here's a typical centrifugal pump. And so as you can see, the centrifugal pump doesn't hit nearly the high pressure that the regen turbine pump did. But the flow goes out much further because the centrifugal pumps are known for their flow, where the regen turbines are known for their pressure. So, and that's where the applications come in for what you would use the regen turbines for, which we'll go over the applications here in a minute. But some of the other characteristics besides the high pressure are that they are a compact design, where when you need to increase pressure with a centrifugal pump, you need to use a multi-stage centrifugal. With a regen turbine, all the pressure is built into a single or up to 4 or 5 stages of a regen turbine that would normally take several, I mean, we're talking 10 or more stages of a centrifugal pump. So you're going to go from a 10-stage centrifugal pump to a single stage regen turbine pump to achieve the same pressure in many instances. And because of this, you'll have simple construction. So you'll have 3 parts instead of multiple stages. Regen turbines are pulsation free, which is different than, say, a piston pump or a diaphragm pump or a some other pumps that use some other pumps in the industry, but the pulsation free means that if you run it through a any kind of a I'm losing my mind here. Anyway, pulsation free flow, free floating balanced impeller means that it's not going to wear as quickly because it can it doesn't touch. As the impeller is turning, it does not touch the walls of the casing or motor bracket. And regen turbines have very good NPSH with little to no cavitation. Because of the way they work, all of the pressure stays on the peripheral of the impeller, which I'll show you here in a moment. And as a result, there's not much cavitation, so we can be put into extremely high, not extremely high, but we could be put into higher temperature situations, all the way up to boiling temperatures, and still be running at very low NPSH, where a lot of multi-stage centrifugals cannot because of cavitation. So moving on to some principles of regenerative turbine pumps. And for this, I'm going to actually turn on my camera because I have a couple of samples that I can show you here. So if you look, can everybody, Jim, are you seeing just me on the
Yes, I am. Yes, I
Okay,
am,
so
Scott. Looks great.
I have a typical regen turbine impeller, which I'll show you in a second. And I have a typical centrifugal pump impeller. Now, the way a centrifugal pump impeller works is the water enters in through the center, and as the pump is rotating, the water goes along the vane, and then it goes along the water channel and exits out the pump. And so it gets one touch of the impeller vane and then leaves the pump. And that's all it gets for touching the pump itself. So it gets one touch and then it leaves. Well, that doesn't build up much pressure, but it can build up flow. The bigger the impeller, the larger the flow. If you want higher pressure, you have to multi-stage the impeller, which is why you have to add all the stacks. So like a Grundfos or a Gould's or a lot of other companies that do the multi-stage centrifugals.
Scott, let me interrupt here for a second. I don't know if you saw one of the gentlemen. I'm seeing you, but it sounds like they're saying that the video froze on their end. I don't know if you saw that.
I don't know.
Is everyone at ePumps seeing Scott, or has the video frozen?
I just turned it back on to the...
Oh, okay, they're fine. Okay.
Okay, so I'll put this back on here real quick. Okay. So here's back at our regen turbine. So what happens with the regen turbine is the water gets introduced into the regen turbine from the center of the impeller. And what happens is it splits. and on each side evenly, which is where the balancing comes from. So the impeller will self-balance along the edge, and the water will rotate, and it'll regenerate itself each time, multiple times. And that's where you get the regeneration, is when it's rotating, it is regenerating each time. And so after it's done this several times and mixed up through the impeller, when it leaves, when it hits the water stop and it leaves, it's got a great amount of pressure with very little flow. And so that's the principle behind how the regen turbine works. So if you look at the diagram, you can see that. Okay, so everybody, you're seeing the diagram now, Jim?
Yes.
Okay. So if you look at the diagram, it shows this water stop right here. So where the water goes in, it goes around and then it goes out. And you can see where it keeps the balance versus the centrifugal where it gets the one touch. So I just wanted to show that real quick so you can see why it can replace a multi-stage centrifugal.
Scott, if I may add here, and you're probably going to cover it, that if you go back to that impeller that you had, the greater the amount of those quote teeth that are on the impeller, you create more pressure.
I don't know if that's accurate. It's actually kind of a mix of impeller versus water channel versus
Yeah.
a lot of that engine that the engineers figure out, because there's some really high pressure pumps that have many vanes, and there's some even higher pressure pumps with bigger diameters that produce, more pressure. It's all a mixture between the water channel size, the number of impellers, and the depth of the vanes. It's kind of a mix. So I don't think that's exactly accurate, but it's pretty close. I do know the bigger the impeller, the higher the pressure and flow. So that I do.
Okay.
And the bigger the water channel, the bigger the flow, because more water can fit through the water channel. So, another one, rotary vane. That's the other one. That a rotary vane has pulsation. Where you're going to find a rotary vane pump that we can replace is in a Procon. So we have a small model we call a T31 or a P31, and the smaller models are good to go after with a Procon pump, because a Procon is a sliding vane, and the sliding vane has moving parts. I believe the wiper vanes are either rubber or some kind of silicon, and they will wear out, and they use springs. And so anyway, that's just to show that there are other types of pumps besides the multi-stage centrifugals that we can replace. And we were talking about the low NPSH. A normal regen turbine pump will run at about 4 to 8 feet with on a large scale. Our little close coupled pumps will run at about 1 to 2 feet, maybe even a half a foot on our really small ones, on our T31s. But when you get into a situation where you've got a large facility and you have a large pump, one of our multi-stage regen turbine pumps, and you're going to be running the higher temperature water, and you need even lower NPSH, using a inducer, which is actually a centrifugal impeller in front of those regen turbine impellers, will lower that NPSH even further, to where it's as low as even 2 feet. Some of them even as low as 1 foot. So we can hit very low NPSH with our pumps, and that's one of our big advantages to our abilities. Moving on to some of the applications. You should be seeing a diagram of a building, and I've just kind of placed some of our pumps where you would typically find them in a building if you were looking for places to put pumps. Of course, pressure boosting is the big one because you don't necessarily need the flow as much as you need the pressure. And of course, we do the condensate return, we do the boiler feed. Boiler feed is where, if you're not familiar, is where you're refilling a boiler that is under pressure. So you need another high pressure pump to be able to overcome the boiler pressure to be able to refill the boiler while it's still running. We do a lot of circulating with the geothermal heating and cooling because you have hundreds or thousands of feet of piping underground. And when you get that much distance of piping, you need to be able to push water through that piping, and Regen turbines are great for that. In a closed loop system, a lot of times you can even do that with our centrifugal pumps, which also includes for radiated heat as well. We are very popular in the fire suppression systems as the jockey maintenance pumps, because our pumps do very well with on-off operation, where they'll turn on for a minute or two to recharge the system and then turn off and be off for however many hours. In a fire suppression system, as you're aware, the sprinkler system works on pressure. If a fire happens, if one sprinkler goes off, they all go off, because the one sprinkler that went off releases a sudden a lack of pressure because all the water is now exiting the system and makes them all go off. Well, you don't want a leak causing all of them to accidentally go off. So the leaks come from a drip in the system, or a backflow in a check valve somewhere, or maybe the city is doing something and you don't want the water flushing back and setting off the main fire pump. So we have a jockey maintenance pump that will simply turn on when the water in the pipeline hits a certain pressure, and turn off again when it's recharged to that higher pressure. In the temperature control industry, we have a lot of our pumps, since they're so precise, can help control the temperature in a chiller down to even 1/4 of a degree, which they use for medical equipment. And it's not just medical equipment, it's also industrial equipment. So they use them in welders, they use them in plasma cutters, they use them in EDM machines. Anything that needs a temperature controlled unit uses a chiller, and we are pretty effective in that industry. As well as circulation pumps. We've recently taken on a new line of Freon and refrigeration pumps that we are circulating Freon up to the roof of buildings in grocery stores and food chain stores, that will use the outside cooler temperature to save electricity, so that they don't have to run the compressors as much in some of the newer buildings. And it's kind of a unique system that's just starting to come around, and we're kind of on the front line of that one, right, Jim?
Yes, we are. Thank you for mentioning that, Scott. I appreciate that.
This is one of Jim's favorite projects right now. So moving on here, water and wastewater applications. Probably our two biggest ones in this industry right now are the sampling and injection, because of course the high pressure, you use the sampling for moving the water across the thousands of feet of piping in any given facility and or wastewater treatment area to a laboratory testing area. And with the injection, you can use the high pressure of the Regen turbine to pump any chemical or whatever whatever kind of additive you need to into clean water system to help keep the water clean or help in whatever process is currently being worked on. And then the other one is dissolved air flotation. And Regen turbines are very good at taking and introducing air into the inlet side of a Regen turbine, and they can handle 20% vapor. And what happens is the Regen turbine impeller itself will take the air and it mixes it with the water and it makes the air into a microbubble. And that microbubble will then go into a trough of sorts that has wastewater in it that will grab onto particles in that water and make them float to the top where they can be skimmed off, and you can clean that water for either reuse or recycle. And they use that for both wastewater, or they use that for wastewater industry. They use that in the oil industry, especially in like that fracking industry where they were producing all the toxic water. They can now reuse that water because they're using the DAF process on that to clean the water enough to be able to be reused. And they're also using it in the food processing industry where they can be able to clean out water after it's been used to clean whatever food, whether it be vegetables, meat, or poultry. And they can clean off the water after they're done with the process to be able to be clean enough to dump into a regular drain so they don't have to put it in a holding tank for special processing later. So Regen turbine pumps are basically good for anything that uses the high pressure circulation. So any closed loop system can use a Regen turbine pump. So in heat recovery systems, hydronic systems, boiler feed pumps, for steam or condensate, which includes industrial boilers and heating systems. We do pretty well with chemical processes, including refineries, textile mills, and wood mills. I'm not going to read all this because I'm going to leave you guys with a copy of the PowerPoint presentation. But I will point out that if you look at this picture down here, back it up. This picture down here, this is a seal quench gland that we use in the paper mill industry. And this tank that's sitting above this pump is filled with oil. And what happens is there's a chemical that is pumped with a stainless steel pump that if the fluid touches air, it crystallizes. So the way a mechanical seal works is the fluid lubricates the seal as it's sealing, and crystals will build up on that seal and make it prematurely fail. Well, what happens is with this quench gland is that it has a lip seal behind the seal, and there's an oil layer between the mechanical seal and the outside atmosphere. And so there's a sight glass in this tank, and it allows the maintenance crew to be able to monitor this tank. And if they see either the oil getting either cloudy or starting to lower in level or raise in level, then they know that it's time to change out the seal. And rather than suddenly have a catastrophic failure and ruin their whole process, they can schedule a maintenance where they can properly clean the system and be able to take out this pump and change the seal properly so that they don't waste any of the material that they were currently working on. And so that's what that tank is. I see somebody asked about that. That's what the tank is. It's a seal quench gland. So moving on here, pressure boosting. We are in a lot of high-rise buildings in the Chicagoland area. I don't know how many buildings we are worldwide, but I know being that we're right outside of Chicago, we hear about the ones in Chicago quite a bit, and other high pressure situations, including washdown. Or in a lot of car washes, because we do have stainless steel. We're compatible with a lot of the chemicals used to wash a car, and we don't have the high pressure that you would necessarily use for like blasting paint off of a car, but we are good for cleaning a car, so we do get used in car washes quite a bit. Boiler feed service, like I had mentioned, we overcome the pressure of a boiler system in a building because of our high pressure, and we can refill a boiler using our pumps. We do have a full boiler feed selection chart on our website, which allows you to look at the boiler horsepower, and it will calculates out the evaporation rate, the the pump rate, the GPM needed to refill that boiler, and then it selects the pump for you at whatever the pressure is in the boiler. So kind of a handy tool if you're replacing a boiler.
If I may add to that, Scott, our website, I believe, is very, very user-friendly. All pieces of literature you can get directly off of our website. There's a lot of useful information. There's flow curves. There's an application side where there are a list of applications. We're filling them in as we go, but a lot of them we have something on. So, I mean, if you guys can take a few minutes, it's worth spending some time just going over our website to become familiar with it.
Right. So, condensate return after the the lines, or after the boiler system in the building or house or whatever has been used up, and all that steam has been turned back into water. It goes into a special holding tank, and our pump gets used to move that water either back into the boiler, so you need the high pressure pump to move it back into the boiler, or back into the boiler feed tank, which you can use a centrifugal pump for. So we have flange mounted variants of many different sizes. In fact, if you see the flat here, it's because we can custom cut to fit either an old Aurora or a Weinman or a Dunham and Bush or a Shipco or a Sterling, or whatever tank is already in existence. We can cut a flange to fit and be able to outfit a MTH pump to it. With the chillers, like I had mentioned, there's a lot of our pumps are so small that they can fit inside the cabinet of a chiller, making them very portable. And a Regen turbine operates at a very low decibel, so it's a very quiet piece of equipment. So a lot of times they just put the chiller right in the same room as like an MRI machine, or a CAT scan. They use them for cancer treatment, for cooling the aiming system for where they're going to be shooting the radiation. They don't want the needle moving around where they're shooting it, so they use a cooling tip, and they use a chiller, and our pump is in that chiller. So a lot of different temperature control, applications. So here's some more coolant systems. Like I said earlier, the geothermal cooling, plasma cutters, anything that needs a cool temperature controlled tip would use our pump at the heart of it. Here's the DAF process I had referred to earlier. You can see this is what I was referring to when it mixes up the air. You can see in this picture, this pump has a hole in it. You wouldn't hook up a compressor to it. You would simply put a valve on it, and turn on the pump, and as it's circulating the water into the tank, you would open up that valve and get the amount of air pressure that you wanted. The pump would naturally suck the air in itself. You wouldn't have to use any kind of compressor. And with that, once you get it, you would have to do is kind of visually look and dial in when you see the right amount of I guess I just call it smoke. When you see the right amount of smoke in the water, then you have the you have the DAF effect going, and it'll grab any particles that are in that water and pull them to the top where they can just be skimmed off. Some of the other uses with the high pressure are seal flushing, filter backflush, extractors, and groundwater remediation. All these processes include where water is already flowing, whether it be from a larger pump or a stream of sorts, and you need to use a higher pressure to overcome the already flowing water to clean something off. So in other words, with the seal flushing, you have, say in a wastewater treatment plant, you have a large grinder pump, and that large grinder pump is a really expensive mechanical seal running in it. And you want to keep that seal life as long as possible. What you would do is hook up a Regen turbine pump next to that large grinder pump and simply run a couple of lines into the seal chamber where it could be feeding it fresh water or effluent water to be able to keep that seal chamber clean and cool while the rest of the larger pump is doing its job. The smaller pump is doing nothing but just keeping that seal clean and cool. Same thing with filter back flushing, kind of rewashing the filter as it's running. Extractors are basically pulling fluid out of engines and whatever in body shops, but I think it's used a lot in like industrial engine type situations and marine situations more than it is in garages. And then groundwater remediation again is where you're using like a series of trays with small holes, and you need to keep those holes clear so that the water can flow without taking all the particles with it. So anyway, we do have a DC motor, a 12-volt motor that can hook up to a T31, several of our C series, and any one of our E41 and E51 pumps up to, I think it's one horsepower. I think technically it's like 1.4, but we only advertise it as 1 horsepower. And what this allows is for you to put it on a truck for portability. We know the biggest industry for this is the portable restroom industry, where they can go to a remote spot that has a porta potty and be able to clean out that porta potty, construction sites and parks and whatnot. But they also, we have cities that use them for watering flowers and all sorts of stuff. Well, we recently discovered that there's a couple of companies out there that have opted to use the same pumps that we use for this application. They're using them with a bearing pedestal, and they're hooking that bearing pedestal up to a PTO, a hydraulic drive, and they're using them for DEF, the urethra they use for the emissions for diesel engines. So that diesel, I forget what it's called. The DEF is what it is. Anyway, so they use that for with the hydraulic drive, and we've been having some sales with that. So that's a good place to look too if you're looking for some odd jobs. And then some of our more technical areas where you're getting into some really precise calculations is with the deionized water. With the deionized water, we're being used in reverse osmosis process, as well as in fuel cells. That's where our can motor pumps come in, where they're able to do super high filtration and desalinization, as well as end up using those in marine applications for making drinking water, as well as in fuel cell applications. So you guys can look this over on your own. I'm not going to go through this whole thing at a later date. So anyway, the fire suppression systems, like I had mentioned earlier, the jockey pump systems on our website, and I'm still working on it. It's about halfway done. It's on my list of goals to get done this year. If you go to our website, you can see that we have a jockey selection chart that choose the main pump rating of the fire system and the main pressure of the pipe system. You'll get an exact selection for your pump. Well, on the website, when you click on this, I'm gonna keep doing this. When you click on the pump, it will actually open up a PDF file that is a selection sheet that will get you the exact curve, the exact dimensions, and it will give you the motor nameplate for single phase and three phase, so whatever the building has, and it will get you the bill of material for both the three phase and the single phase in bronze fitted, which is the most common needed for a jockey pump. So like I said, I'm about halfway done, and when that's available, then you'll be able to use that to hand into any contractor and or city inspector as you're building the system, and it makes it a lot easier for submitting drawings and paperwork. So high pressure coolant is another one. We use our M series, anything from our T51s up to our M series to get that 1000 PSI. And with the high pressure coolant, what we do is they blow that 1000 PSI onto cutting tools, and it cleans the cutting tools at a microscopic level that extend the life of a cutting tool massively, and also reduces the machining cycle times because those parts are so much cleaner as they cut. It's like making that first cut over and over again. And then hydrostatic testing. Any facility that makes tanks, valves, pumps, or piping has to have some kind of regulation as to how much pressure that tank, pump, or valve can handle, and or some kind of leak test. And so we use our pumps because they're made for the high pressure without the high flow. You can simply hook up our pump to, clog all the holes in a tank or a pipe or whatever unit you have, and hook our pump up to it with one inlet and one discharge on a valve with a pressure, and simply let it run at whatever pressure you need to test it, and check for leaks and move on. It's a quick and easy way to do hydrostatic testing without having to mess with air pressure and everything else. So hydrostatic testing. And then we have pressure injection, spraying and misting. With the pressure injection, you can put, we use that for infusing curing agents into concrete, as well as they put wood into a vessel, and then they close the vessel and inject the creosote into the wood using the high pressure pumps to make treated wood for your decks and your parks and whatever else that has the outside wood. And then with the spraying, obviously any kind of cleaning. I believe at the poultry plants, they actually use the spray to blast the feathers right off the chickens with that higher pressure, and it doesn't do any damage to the meat afterwards. So I apologize if there's any vegetarians out there. But and then the misting, the interesting part about the misting is that we can do any kind of pressure up to 1,000 psi. But what it does is it creates a high pressure mist that can be blown using a high powered fan over any kind of demolition or construction area to keep the ground wet and or the air moist so that dust doesn't overtake the area. We had recently had just last, I think it was March, in the Chicagoland area, right while they were doing all the protesting. There's a neighborhood on the south side of Chicago that's predominantly a black neighborhood, that just north of it, they took down a tower that they had scheduled for demolition, and the dust that was created from it made it look like a war zone in that entire neighborhood, and the whole neighborhood panicked because it was just during the riots, and a whole big mess with the city happened, and I guess the demolition company is no longer in existence because they got sued out of business. And the whole thing could have been prevented had they just had a couple of these misting machines to do a little bit of dust control. But I like to tell that story. I just think that's comical. Anyway, and then again, we have our smaller pumps, our P31, our T31s. That get used in the laboratories for anything that needs fluid moved at high pressure, or anything that you need to use the high pressure to run over something to create a vacuum or evaporation or distilling. High temperature. We're pretty good with the NPSH. That's where the NPSH comes into handy. And then with the sampling, moving water over thousands of feet without adding the flow. So it doesn't matter if it's 100 feet or 1,000 feet, you can use the same pump and it creates the same amount of flow, and the pressure isn't really affected because it can overcome that pressure. So you can take a sample from anywhere in the process of a factory or facility and move it to a laboratory, take a sample of it, and then either put it back or do whatever you're going to do with your sample. So, and then we're just about done here. This is the talking about chemical compatibility. Our main materials of construction are bronze fitted, all bronze, all iron, and stainless steel. And we have several different elastomers as well as several different seal variations. So like I had mentioned earlier, we do have 2 full-time application engineers, and anything you have that's non-water that you have questions about, they're readily available. And anything that gets even more complicated than that, we have a full engineering staff that likes to entertain any special OEM projects or anything. So if you do have special projects, let us know. And then future training seminars, specifics of okay. Do we have any specific examples of non-water applications we should be pursuing? Actually, a lot of our non-water applications include things like glycol-based fluids in the cooling industry. There are some. I'm trying to think. There are some things that have acidic levels that you have to be careful about. There are some fluids that change viscosity as they get warmer, some oils. Especially with the oils, a lot of oils will change viscosities as the temperatures change. And so anything that has an oil in it, you kind of want to check with our application engineers. Anything that's got that's going to be thicker or thinner than water, or have a chemical compatibility issue, you're going to want to double check unless you know what is proper to pump. You're going to want to check with our application engineers. Flammable liquids, we've been told that we can only handle a flammability level of 2. I think that's right, Jim.
Yeah, that's about it. We
know that some of our customers do some diesel and some jet fuel type things, but that's kind of on the down low. But we can't purposely sell anything to a flammability level of above 2.
If Scott, and let me add a little bit. I've spoken to Jim McCauley, who is one of our 2 applications engineers, and I think this is something that if anyone wants to pursue as a salesman out in the field, to really give him a call and bounce it off of him to see what his opinion is and what we can do. I don't want to, and as Scott said, I don't want to lead anybody to believe that we can do anything above 2, but check with Jim McCauley. I think that would be the best way to start off.
Right. So, yeah, and then like I said, some of our other future things we're going to have, Jim had mentioned that our website is this plethora of knowledge that a lot of people just haven't really explored. And with our website, you should be able to select a pump of almost any situation right off of our website. And we have crossovers on there. We have selection tools on there. We have tables on there. We have manuals. We have brochures. And a lot of it isn't hard to find. It's just being shown that it's on there. We have accessories on there, all sorts of things. So, and it will take every bit of an hour to show you where they're all at. So that's one of the future things that we're going to do. Standard products doesn't take that long to go through. It's just to give you kind of a lowdown on all of our standard stuff, and then maybe show a few of our new stuff and our custom stuff. Live factory tour, I haven't really approached yet, but I have a feeling when we do it, it's going to have something to do with me walking around on with my cell phone and just showing you guys around the factory. I don't know how exciting that will be. These are just ideas right now. How regenerative turbine pumps work, it'll probably be a little more detailed than what I showed you today with my little samples. And then reading the pump curves is going to be really kind of in depth with, especially with the viscosities and how to work off the efficiencies and some of the other aspects of a pump curve that weren't covered at all today. And then I'm not going to say reading MTH price sheets. It's just kind of how to make sure that you're pricing up your pumps correctly, because there are add-ons for different kinds of pumps, and you just want to make sure that you have everything right when you're using our price sheets, so that you don't have to go back to the customer and realize that you forgot to add a seal, or a seal material or something. So that's what that's about. So other training modules coming. I haven't quite built them yet. When COVID hit, all of a sudden I had to go from us visiting customers and showing them all this to doing it all online. So that's where we're at. So anyway, here is a list of all our inside people right now, all the key people. And like I said, you're going to have this entire presentation, so you can refer to this anytime you want to. And that pretty much concludes everything I had. Were there any questions that anybody had? Jim, did you have anything?
No, I don't think I have any. If in fact David Rhodes is down there, David, I'm going to send you this list that is on the last page here. I'll send you something too as a PDF. So if you want to, print that out or give that to each of the salesmen, that would be fantastic. Right. Along with the fact, if you could let that also too, that if you could let us know all who was in this training, their names, and I've got a list that I just realized I had that you had given me or sent to me as an email.
Well, the names, the certificates, really an email address to make sure you guys are getting all the latest information, especially when it comes time for if we have new price releases. You definitely want to be on that list. So you make sure you get the newest prices. And we're not gonna spam you. I bet you we don't send out more than 1 or 2 emails a month, if that. So, you don't have to worry about spam.
If there's not any other questions, we can wrap this up. So I hope that this was really helpful to you. Scott does a great job on this, and great. I appreciate it. It sounds like we can do it a wrap, Scott.
Yep. Thank everybody for coming on today. And my email is on this list, as well as you already have Jim's. So anybody who needs anything, feel free to go ahead and ask, and I can get you that information anytime. So really appreciate you guys coming out, and look forward to working with you.
Thanks, Scott.